Hey Ms. Wicker, this is Daniel and this will be my operon project. First off, I'll be demonstrating an inducible operon. This will be my regulatory gene, my promoter, my operator, my RNA polymerase, my active repressor protein, my inducer, my structural genes, ribosomes, polycistronic mRNA, and my proteins. As you can see, the active repressor protein is currently bound to the operator, thus blocking all transcription of structural genes. Yet, when we introduce the inducer, it actually releases the active repressor protein and creates an inactive repressor protein by binding to it. This then allows us to transcribe the structural genes. The ribosomes here help transcribe and create all the necessary proteins as well as mRNA coded for by these structural genes, thus completing the inducible operon. Next up, we have the repressible operon. As you can see, this operon is currently active and transcribing the structural genes as shown by the ribosomes producing the necessary proteins and mRNA. This is due to the fact that the repressor protein is inactive by default and thus requires a co-repressor to activate it and then bind to the operator. When we activate it with the co-repressor, it then halts all transcription of the structural genes and thus halts the production of all the proteins and mRNA. That is how a repressible operon functions. In conclusion, the inducible operon requires an inducer to begin transcription of structural genes, while on the flip side, the repressor operon requires a co-repressor to stop transcription of these structural genes.